Okay, in this problem we're given, Louis, the French cook, was boiling pasta for his dinner party in his house. He decided to take a nap since the water would take a long time to boil. Unfortunately, he fell asleep and he kept the water boiling for a long time. So he quickly turned the heat off and let the water cool. After 15 minutes, he measured the temperature of the water to be 80 degrees Celsius. If the room temperature is 15 degrees, what would be the temperature of the water after 40 minutes? So, first we gotta understand that the problem given to us is going to apply Newton's law of cooling. So, given this formula, we can derive the general form by first isolating the temperatures in one side and the constants with the derivative over time on the other. So after integrating both sides will then be raised to e to remove the ln function of the temperatures, giving us with the general equation temperature of the object minus the surrounding temperature is equal to c constant e raised to the k constant times time. So after we derive the general formula for the equation, we can now solve using the three equations given to us. So at time interval 0, the temperature is measured to be 100 degrees Celsius. So here, we can substitute the temperature and time to the working equation to solve for C, which equals to 85 degrees Celsius. So now after we solved for the value of C, we can now apply it to the second working equation. So here we'll be using the intervals time equals 15 minutes and temperature equals 80 degrees Celsius. So after substituting both values to the equation, the values for time equals 15 minutes and temperature equals 80 degrees, we can now solve for K by first isolating both sides and cancelling E by multiplying everything to ln. Here, now we are left with 15K. We just divide both sides by 15, and after solving, we arrive with K is equal to negative 0.017884265. Now that we're given the values of C and K, we can now solve for the final temperature of the object at time interval 40 minutes. In the general formula, we substitute time, C, and K So here we have to isolate the value of t in the equation, which simply leads us to t is equal to 85 e raised to negative 0.71537063 plus 15. leaving us with a final temperature of 56.5659 degrees Celsius. So after we solve for the final temperature, we can now plot a temperature versus time graph. Since water does not boil above 100 degrees, we could use 100 degrees as the start of our y axis. Since we know that room temperature is 15 degrees, we could say that the x asymptote is 15 degrees. Meaning, as time reaches infinity, temperature will not go below 15 degrees. It actually approaches it. So, we are given a downward sloping line.